All right, so before we stopped at the little example about the mosquito that I think might help with visualizing this chart that we all need to know. So at the top, I put central nervous system, then peripheral nervous system. Then we have the sensors. We have visceral and somatic sensory divisions. Or you have your organs and your skeletal muscle, your skin, um, things like that. So visceral and somatic is there's sensors that go into right here to the afferent or sensory division, up to the peripheral, up again to central nervous. Then there's a response back down to peripheral nervous system (PNS), down to efferent or motor division, down to visceral or somatic. Right, so you have visceral or somatic again over here. Then you have one thing that we have to explain down here: sympathetic and parasympathetic division, which is a subdivision of the visceral motor division. And you're going to see that on slide 12-9. It's a little confusing, but one thing that sets them apart is, and I'm going to write it right here. So we're going to start with sympathetic division. It says it tends to arouse body for action. So gets you ready for action. And I'm going to put right here, it accelerates your heartbeat and your respiration. It pretty much, it accelerates your heartbeat and respiration. So accelerate heartbeat, heart rate, and respiration. Yet, I'm going to put here, yet inhibits digestion and urinary system. So it inhibits digestive and urinary systems. The parasympathetic, which is its counterpart. So I'm going to put here parasympathetic. That actually calms the body down. So it has calming effect on body. So you want to think about meditating. It slows down heart rate and respiration, yet promotes or stimulates digestive and urinary systems. So those are the last two. I'm going to tell you right now, go through this chart, go through the book and read 12.1 over and over again. And then you should read this before you go on as best as you can and try to answer those, right? So what is a receptor? Give two examples of effectors. The effector, I know it's on the book, but it's on slide 12-8. Cells and organs that respond to commands from the central nervous system. So an effector is just a cell or an organ that responds. All right. Now, so let's say if you have a negative feedback loop, let's say you have a fever and you need to cool down, you need to reduce your body temperature. The organs or the cells that do that in response to the brain and the central nervous system telling them, hey, it's hot, you're getting hotter. The cell in the gland that actually help with cooling you down or reducing the fever, those are your effectors, okay? Those are the ones that actually do step number 3 in carrying out a task. And you can see that it's in the name, an efferent division, so motor or efferent division, you have your effectors. It's those things that carry out step number 3. And those are your motor neurons. So I would read that. So we're done with the confusing part of the chapter. Honestly, the very first part of the chapter, and we went over a lot of stuff so far, and this is literally only like 10% of it. This is the confusing stuff. So you have to get this flow chart down. You have to understand what everything there is, because now we're going to start talking about properties of a neuron. We're going to talk about general functional classes, and That's easy. That's very, very easy to remember, and we're going to fly through that. So give me 1 second. I think we have 3 more minutes before I have to actually cut this video. So the 3 universal properties, right? 3 universal properties of a neuron. Number 1, excitability. Read more on that on slide 12-13. We have conductivity. So it's very similar to a muscle cell, except that this one has secretion. I think a muscle cell also has secretion. But yeah, excitability, and in parentheses, you're going to have irritability. Irritability. So those are the 3. Go deeper if you want. Next we have general. So 3 general or functional classes. 3 general / functional classes of neurons. We've actually been talking about this a lot already. Number 1 is, this would freeze. All right, so number 1, what the fuck? All right, so number 1, forget the computer. Sensory neurons, sensory or afferent neurons. There you go, back. Sensory or afferent neurons. These are the ones that sense. These are the ones that carry out step number 1, which is receiving the information. The second one, interneurons. This is step number 2. Interneurons. And the third one, efferent. Well, motor or efferent. So motor or efferent neurons. These are the ones that actually carry out the message. These are the ones that carry out the message to the effector, to that cell or gland that actually receives the information and actually does the output. So if you want to think about, and we're almost done here, so if you want to think about like a computer, right, with input, process, and output, your keyboard is an input device, and when you type on this letter H, that is processed in the CPU, right? So step number 1 is my keyboard, me physically tapping on these H's. Those are my sensory neurons sending the information from the sensory division up to the peripheral nervous system, up to the CNS, which is my hard drive, my memory, my RAM, all that stuff, the CPU, my processor. The output is a screen telling me I have 1, 2, 3, 4, 5, 6, 7 H's on my screen. That is step number 3. After the computer realized that I was tapping on the keyboard, it processed that. That's step number 2 with the interneuron. Step number 3 is shooting out all these 7 blue H's on my screen. That's with your motor efferent neurons. Motor or efferent. It's not motor efferent. It's either motor neurons. You can call them efferent if you want. He might ask you that on the quiz. So that's that for most of the confusing stuff. And now for the next video, we're going to get into the actual structure of a neuron. We're going to talk about neurosoma. We're going to talk about dendrites, the axon hillock, multipolar neurons, bipolar neurons, unipolar, anaxonic, and axonal transport. So I'll see you guys in a bit.